number that gives us information about how two vectors compare to each other. The way that we find the dot product is we take the horizontal components and multiply them. We take the vertical components and multiply them. And then we add those two things together. So when you get an answer for a dot product, it should be a single numerical number. So it's going to equal some number. 5, negative 12 and a half, something. So this is going to equal just a number. You're not going to get like another vector or something out of it. That's not a thing. Also, oh, that comes up later. Okay, I'll wait to say that. Another formula that you need to know is this one. So this formula says that if you want to find the angle between two vectors, so you have a vector and you have a vector. If you take the dot product and you divide it by the magnitudes multiplied together, that's going to give you the cosine of the angle. So to figure out the angle, you would take the inverse cosine to find it. I'm going to pause for so we're going to use these two formulas, and we're also going to see another application problem because after Friday I saw how much you loved them and I knew you wanted more. All right, example A. I'm going to give you vectors. They aren't here. Again, the only reason they aren't here is because the formatting is challenging. Okay, so add these in. Listening, please. Okay, so these are the two examples that we're going to do. All right, so it says, step 1, find, and then it says nothing. We want to find the dot product, is what it should say. Dot product. And then step 2, we're going to find the angle between the two vectors. So those are our two things that we would please like to do. All right, so let's start with dot product. You'll want to do that first because the dot product is a part of finding the angle anyways. So that helps us do part of the second one. So let's find the dot product. Are you ready? It's not hard. 3 times 1 is? 3 plus negative 5 times 4.
Negative 20.
Good. And negative 3 plus negative 20 is?
17.
Negative 17. So this is the answer for the dot product right here. So again, it's just a single number. It's not a vector. It's not, I don't know, extra bonus stuff. It's just a single value. Now I'm moving on to step 2. So I need that to help me. Do you see how that's the numerator of my fraction? I also need, listening, I also need the magnitude of u and magnitude of v. Let's find that next. Let's start with the magnitude of u. Remember, this is your notation for magnitude. Equals the square root of, what do I put under the square root? 3 and 5, but yep, we're squaring both of them. This one would specifically need parentheses because we want to make sure that we square all of the negative 5. Grab Pinky. So let's find that value first. So we've got 9 plus 25. So we've got the square root of 34. So 5.83. Remember, I like 2 places after the decimal, please.
5.8.
Is that not what you got?
Oh, someone got that.
Okay, next. I'm going to go for the other one. Square root of 1 squared plus 4 squared. So we've got 1 plus 16, so I've got the square root of 17 on my hands here, which is 4.12. Okay. Guys, I really need you to pay attention. Let's stop the side conversations. You can chat when we're done. These won't be super long notes, I promise. Okay, we have the dot product. That's one of our answers. That was part 1. Now we need to find the angle in between. And we have all the things. We know the dot product. We know both the magnitudes, so we can set up that problem. So the cosine of theta equals the dot product is the numerator divided by the magnitude of u times the magnitude of v. So 5.83 times 4.12. Okay, so I'm going to get cosine of theta equals whatever this mess is. Negative 17 divided by 5.83. 5.83 times 4.12. Make sure both of these are in the denominator together being multiplied. Did we get negative 0.707?
Yeah.
Or 708 when you round up?
Yeah.
Did we get this? Okay, now, how do I undo the cosine to figure out the angle between? Second cosine on the calculator, which is the same as doing the inverse cosine, right?
Yeah.
So second cosine, second answer, and I get theta equals about 135 degrees. And it says to the nearest degree, so I'm not going to even do a spot after the decimal. So this is the angle, this is part 2. That is the dot product. That was the first thing they asked me for. So again, do it in that order though. It doesn't always help to do it in the order they give it to you, but this time it does because we need the dot product to help us find the angle. Okay. Do you think you can do part B by yourselves?
Yeah.
Try it. I'm going to pause my video, see what you can do without me. Now, before, do you see how it's not in component form? What's component form? 4-1, right? Like this is different, but is it really? No. Okay. Okay, do part B. So here's my answer for part B. Again, I just left them as the square roots. We can find the decimal equivalent or you can leave it like this. It doesn't matter which way you want to go. Now, here's a special property. When two vectors are perpendicular, perpendicular means what angle? 90 degrees. When two vectors are perpendicular, the dot product has to be 0. So, why does the dot product have to be 0? Let's think about that. The cosine of theta is equal to u dot v all over the magnitude of u times the magnitude of v. Right? That's the formula we've been using. If I want to start kind of simplifying this down a little bit to figure out just what the dot product should be, if I multiply each side by the magnitudes, so I'm multiplying by the magnitude of u, magnitude of v. And I also have to do it to this side because it's an equation. Whatever I do to one side, I have to do to the other. Do you see how these will cancel out? Do you agree? Okay. So I get u dot v is equal to the magnitude of u times the magnitude of v times the cosine of theta. All right. If we meet at 90 degrees, that means my theta is 90. Okay. So let's think about 90 degrees for a second because we're saying we specifically meet at a 90-degree angle. So here I am, I'm up here. What's my cosine value up here? 0. So the cosine value is going to give me 0. So 0 times the magnitude is just going to be 0. So that's why the dot product has to be, I don't want an equals there actually. I'm going to do like an arrow again, I think. You can write it however you want. So I'm saying you're putting in 90 for the cosine. Well, what is the cosine of 90? It's 0. And 0 times all this stuff is still 0, which is why the dot product has to be 0. So if the angle between two vectors is 90 degrees, the dot product is going to be 0. So let's look at the next one. It says, I'm only going to do one example like this. We don't need to. Two non-zero vectors, u and v, are perpendicular if and only if u dot v is 0. So I'm going to give you u, and I'm going to give you v, and you're going to tell me if they're perpendicular. So all we need to do is calculate the dot product and see if it's 0. It's a simple test, okay? So if it's 0, perpendicular. If it's not 0, not perpendicular. So it's a pretty simple one. Okay, so find the dot product. 12 times 1. Negative 2 times 6. So it gives me 0. Are they perpendicular? Yes. Have you seen the symbol before, the 3 dots? Do you know what it means? Therefore, yep. So therefore, actually I don't want the magnitude. Therefore, vector u and vector v are perpendicular. And again, we have that little proof over off to the side about why that's true. Flip when you're ready. We're almost done. You're fine. Okay. Next, I'm going to come down here to work. We're not going to do a third example. Come down here to work. Okay. If you're doing work, work is also a dot product situation. So when you are calculating work, work is equal to the dot product of force times distance. So F stands for force, D stands for distance, W means how much work is done, and this doesn't mean times, this means dot product. So make sure you know what all the things in the equation mean. Shh, listening. Okay. A force. Let's do an example with it. A force given by a vector moves an object from 2, 1 to 5, 6. All right, let's figure out the distance that was moved. So we have a distance that occurred, and I'm going to write it in component form. Remember that it's always terminal minus initial. So it moved it from here to here. So this is my terminal. Terminal, 5 minus 2. My horizontal component is 3. 6 minus, we're finding the distance between the 2 points. So work is equal to the dot product of force and distance. So I need to know how far this point got moved. 6 minus 1, 5. So this would be my horizontal component, vertical component for the distance it was moved. All right, so we have a, we need the force vector too. It didn't give you one. I'm going to give you the force vector. It should have given you one. It didn't. We're going to go with 7, 6. Meaning in terms of force, you've got 7 for the horizontal and 6 for the vertical component. So that should have been given to you. That's not me doing math. That should have been there. Again, we have trouble with the formatting on these. Okay, so to find the amount of work done, we're going to take the dot product with force and distance. So 7 times 3 is 21, plus 6 times 5 is 30. So that gives me 51. And it looks like I just always write joules in there. I don't know. Whatever you want to use for your measurement for work, it's not giving me one here. There are different measurements that you can use. I always just write in joules because I feel like that's typically what we measure work in. All right, we're going to do one more example problem that could also appear on your quiz on Wednesday. So today we're learning new material. Tomorrow we're reviewing. Wednesday we're quizzing. And then Thursday I don't have you for very long because we're doing like all these assemblies and different things. So Thursday is going to be like an extra credit / catch up sort of day. So Thursday is not going to be anything super tricky. if you are going to be gone early, if you're like, I'm only here till Wednesday, ask me for the sheet on Wednesday. I'll give it to you. You can bring it when you come back. Sound good? Okay, hold on. We're not ready for homework. We got one more problem. We've got a man pulling a wagon. You guys, we're back to my amazing drawings. There's a man pulling a wagon.
Sure he's not pushing it?
No, he's pulling. It's obvious by the picture.
No.
I'm pretty sure it is. Okay. The work is equal to the force and the dot product with distance. Let's start with the distance because the distance is actually easier. What does it say about distance? How far did this person pull the wagon? 200 feet. So, 200 feet is the horizontal or vertical component? Horizontal. And actually, I don't even want it like this. I want the component notation. So 200 feet. And then it's on a flat ground, so we're not moving anywhere vertically. If there's a vertical change, they'll let you know that, like, oh, and the elevation changed by 5 feet over the course of the 200 feet. So we would let you know that information if there was some. So we have that part. Then we need to find the force. So we have got
30 pounds.
30 pounds of force, yes. And when we're looking at it, we've got the handle makes a 70-degree angle with the horizontal. So if I'm thinking horizontal like this, I'm making a 70-degree angle as I'm pushing this wagon. So when we go for the force, we're going to find the horizontal and the vertical components. For horizontal, we've got 30 for our magnitude. So 30 in this case is the amount of force. So it's 30 pounds times, just like what we were doing on Friday, the cosine of the angle measurement. How am I going to find the vertical component? 30 times the sine of 70 degrees. So what I'm calculating right here is the component form for my force. Do I know 70? Is that one I know? No. Okay, make sure you're still in degree mode. If you're not, you need to switch back. So for the horizontal component, I get 10.26. And then for the vertical component, I get 28.19. All right, so do we have component form for both the force and the direction? Yeah, so those are the two things you need in order to get to work. So now we're going to take these two, multiply them, these two, multiply them, and add them together. Well, what's this going to do? It's just going to be 0, a whole lot of nothing. There's no work being done in the vertical direction because I'm not like curling the wagon, right? Like I'm literally pushing it along the ground. All right, so I'm going to do 200 times 10.26, 2,052, and this one's in feet pounds. Feet pounds of work. So again, there are different measurements out there for work being done. I always just randomly put joules with the last one because we've got not very much information. This one we have enough to say feet pounds worth of work. Questions? It's given to you in the problem. All right, homework for tonight. Page 596, numbers, and this should really be your last homework because tomorrow we're going to do a review in class, and usually you guys finish those. So tomorrow I'm not really super worried about that. If you have anything, it won't be much. So you can kind of think of this as your last homework assignment to get you to spring break. because there won't be homework the day of the quiz, and there's just extra credit the day after that. Okay, so this is your last book work before break. That helps you kind of get there.